Okay, I'm going to give you a brief little video help for your homework, which is actually the exit ticket. It's the back of your entrance ticket. This is what we did in class. You go to the back here. So you might need to refer to the notes, and I think I thought I had them open. Hold on just a second. Let me go get to those to help you with some problem solving. Okay, sorry, got it open. Finally got it working. So it's this foldable that we worked on, talking about the characteristics, our constant of variation. That's the K. That's when we're looking at the ratio y over x. We did that on these first 6 problems here. And then the equation of direct variation is just the y equals kx. And then remember, the graph should be a straight line through the origin. So we did talk about checking for direct variation, checking the ratio, make sure they all are the same. And then we also looked at the graphs, what they have to match to be a direct variation. And we have this last section we need to talk about, and we'll address that in class. So on our exit ticket here, because they want you to determine if it's a direct variation or not, that goes back to the tables that we did. Sorry, there's a delay. There we go. Right here. So this is to determine if it's direct variation. We have to do the ratio of y over x and check each value. So for this, remember, we're doing y over x. We're checking the value of each. So here, we want for it to be a direct variation, it has to come out to the same number each time. So check this and see if it's a direct variation, and if it is, then that constant change is your K, okay? Here on 7, the number of baskets she makes varies directly. There it is. It tells you right here. Varies directly with the amount of time. So it's baskets to the amount of time. So we know she can make 4 baskets, and I think this is supposed to be 4 baskets in 12 hours. I think there's a typo right there. So how many baskets could she make in 5 hours? So how many baskets would be X, and the hours, 5 hours, would go here at the bottom. I believe this is going to be a decimal answer. Maybe it's not 12. Maybe it's 2. Yeah, okay. Maybe this is supposed to be 2. We'll discuss in class. We will go over these. So, all right. Again, given our points here, x and y, x and 42, what part of the same direct variation we need to find x? So remember, if it's a direct variation, it follows the formula y over x. So if I set that up with our points here, with the first point here, because 3 is your x and 21 is your y, this is 21 over 3. And now I'm trying to find x, so that's on the bottom, and our y is 42. So hopefully, remember, we can cross multiply to solve this. So number 8 and number 9 are very similar to solve. You do need to vary y over x. Okay, y varies directly with x. If when y is 39, x is 3. This is when find the value of y. Y is the value on top when the x is 2. All right, and then the last 2 questions. F of x is the curve here. That's the function of x. Find f of 3. Remember, the number inside the parentheses represents the x. So we need to find the value of y when the x is 3. So 1, 2, 3. Here's where the 3 is. Go up and touch the graph and find that value. Oops, I don't know what happened here. There it is. Okay. And then 11, another Starlight question. What is the range? Remember, range is dealing with the y values. That's a hint to your answer choice. And range, we look from our bottom to the top. We're looking at the we need to find how high the graph goes, how low is the graph going. And then after this, you're going to definitely start on this because you're not going to have full class time to do this, but this will be a separate grade. You will need to go to, let me go in here, here's a mock student. You will need to go into progress learning and you want to go to assignments, which is what's showing. And then we're going to go right here to the expanded view. So there's two assessments in practice here. We have domain and range, and then direct variation. You're going to hit begin. And I'll just kind of go through some problems with you and some of the tools that you have. You need to do some scratch work on a separate sheet of paper when necessary. Okay, so here's our example of a problem that you have to do. This is a part of the quadratic function is shown. So this is the quadratic part of it. What is the domain? And I'm going to go ahead and I'm just going to expand my view to get to my drawing tool here. Remember, you have that as an option. So the key to here is domain, knowing that's an x value, which they've already showed in our inequality here. So when I'm doing domain, I'm scanning from the left to the right, but I have to look at the x values. I have to look up and see that x value. Here I'm going down to see that x value. And they're closed dots, so they've even already set us up here for that. So I'm going to exit out the draw tool. We know we're going at 1, so I could put the 1 here. And then it's less than or equal to the 5. I'll put the 5 there. And then we're going to hit next. Okay. Now, for something like this, because determine the domain and range, like I need a graph to be able to determine that. So I'm trying to see if the graph, the calculator is not showing here. All right. All right, so you're gonna need to go to Desmos calculator. Hold on, let me show you where that's at. So you go to Texas Desmos calculator. There it is right there. Here we go. Okay. So what we're gonna do, and I'm surprised the calculator's not opening on this. I'm gonna double check on this. I'm sorry, apologize for that. We gotta put this equation into our calculator. So h of x, 3x squared. So I'm gonna type in h, oops, nope. X equals 3x squared. Now on here, to get to your exponent, I normally would do Shift-6, but right here, if I click this keypad, I can see my option for exponent. So I think we had, what was it, 3x squared minus 12x. So minus 12x x, and then plus 26. So I'm going to go back. There it is. All right, so, and we're going to pull up. Wow, I feel like I'm forgetting something. Oh, there it is. Look, you have to zoom out. And there is, I can drag it. This is why I'm doing this. I can drag it over and look. There it is. Okay, so this is a parabola that's going to keep going and going and going and going and going. So I know it doesn't show the arrows, but we have arrows on this parabola. And I believe it's asking us to calculate the domain. So if it keeps going and going and going, never stop, that's going to be all real numbers. But our range, that's when we scan the bottom of the graph. And the bottom of the graph, I can literally click on here, is at a value of 14. And then, because that's the x, the value, it goes 14 and then it keeps going up to positive numbers, to 20, to 40 right here. So now you have to determine which inequality would I be using for range. And that's, you have some hints here. We know we're not picking anything with the x, domains are x's. So hopefully you recognize we're using this value. Oops. Get it in the box, and there it is. All right, and then we're just going to go next. So you're going to work through these problems. Another one where you need to look at the graph to help you. And I'm going to save and exit. But you're going to do this, and it will score it at the end. I'm going to save and exit. Because I believe, like, exit here. If I go back to your lesson here, expand view, there's two parts here. So there's the domain range, which you can continue, or then we can go to the direct variation practice. So when you get to here, you're going to start, and you might want to refer back to these notes that I was talking about for direct variation right here to help you with some of the problem solving and the characteristics you're looking for. So when I look at this problem here, and I'm going to use my draw tool, sorry. So we know that the amount of money here, it varies right here each week, directly proportional to the amount earned. So last week, you saved 32, earned 512. Saved 32, earned 512. At the same rate, that's what this says right here. Sorry. Same rate, I'm going to exit out just so you can, there it is, so you can read it. How much would Charlie have saved this week if his earnings was for 48? So saving, this is saved on top, earning on the bottom. So if saved for how much did he save for his earnings of 448? So what we can do now is create a proportion so you can cross multiply to solve. Okay. I think on this one, because we're doing an assessment, yep, you have to solve it. I'm just gonna check. I'm just gonna do a random one. When we go next. And then it will, obviously I picked the wrong answer, but it will give you an explanation. So take the time to read what they did to solve it, and then you can re-evaluate, I believe, and then close and go to the next one. So remember, this is a direct variation because it goes to the origin. The y varies with the x. So assuming that speed remains constant, how far could the car have gone after 2 hours? So if it's 300 miles, oops, get that pen going. There it is. If it was 300 kilometers after 5 hours, then it says how long after 2 hours. So again, set up a proportion, or you can look for a pattern, right? But please get this done. Like I said, this is a grade, and it will timestamp for it being done on time as long as it's completed by Thursday. We are going to be moving on to slopes and to rate of change, which hopefully would be a review skill. So we can pick up and build off of that. Hopefully this helped. and come to class with questions, but you will be turning in your tickets and then your work to anything that you did here for the progress learning. All right, thanks guys.